Hi, welcome to this day 2 of the map challenge. Today I'm just going to show you how to display a line data. Essentially we will just use this script. I will put down the source code also in the description. Sometimes you want to calculate, for example, how long it takes somebody to walk from a certain place to a certain facility. And there are a lot of literature that says because every road network is different or constructed differently, then it's important for you to compute the nodes or the intersection point, and then you use the intersection point as a proxy to estimate how long it will take someone to walk or cycle or even to drive to a certain location. So this is what this code is going to do, and for the purpose of day 2, which is to display a line data, we will try to only display the road network, and then in the subsequent days in the challenge we will try to also demonstrate the other part. So the first thing you would want to do is to install these libraries, and the OSMNX library. Basically we will just give it an alias. You can change it to anything as you want, but what this library does is mainly used to retrieve, construct, or even analyze street network from OpenStreetMap. So you get the data directly from OpenStreetMap, and then you can visualize your data. This is the pie plot. It's a model in Matplot that will help you, give you a MATLAB-like interface to just plot your data. So the first thing we have to do is to just select a city. So you can always change the city name to your own, and then the country. What you need to know is that you have to make sure that you don't spell the name wrongly, or you also have to make sure that you have the local CRS of your place. So never use the geographic coordinates if you want to do measurements, or if you want to calculate an area or something like that. So that is what we have done here. The next thing is to use the graph from place, which is embedded in the OSMNX. This helps us to just retrieve the street network data for the specified place here. So it gives us a two input variable, which is a city name and the type of network that we want to analyze. And the projection .project graph is also one of the functions within the library that also help us to project our graph to the required CRS or the specified CRS. The next thing we would like to do is to simplify to get some real intersections. Like I said before, if you just compute the nodes, for example, in big cities you are going to get so many nodes, because of course some of them are constructed that way, some of them too are made from by human intervention. So what we will do is to just use this model in the ox.simplification function, just to simplify the number of graphs that we have. And then we will set a parameter or a buffer of 5 units, and this mainly mean that this parameter will help us define all the buffer distance around each node that is within a certain 5 units from each other. So for example, if you have 5 units within that are close to each other, it's just going to sum them up. We will also set the rebuild graph to true. Yeah, this basically to just help us simplify the nodes as a geodata frame. The next thing we will do is to also use the graph to GDF's function just to convert the graph that we already have here into a two geodata frame. So this two geodata frame, one is going to be for the nodes and the other is going to be for the edges. And like I said, you are doing this because you don't want to compute an accessibility network just for every road. You would like to use the intersection as a proxy instead. So the next thing we will do is to just set up the plot and yeah, just to set these few parameters depending on what you would like to, which color you want, the size of it, and then if you also want to save it or just plot it within the map, within the notebook. So you end up with something like this, but like I said, because our main focus is to compute an accessibility analysis with road intersection, you may also plot the edges that you've made here, because we had two, one was the nodes and the edges. So here we would like to also plot the edges with these few parameters. So you can either show each one of these, either the one showing the nodes or the roads itself. Like I said, this is just part of a full code that helps us analyze how quickly we would like to service a certain, or we would like to access a certain service from a node. I hope that you will be able to manage it. You can watch my other videos on how to set up a notebook environment or a Conda environment, and then how to also install some useful packages. I have more than 180 libraries that you can automatically install them, and then you'll be able to run this. When you are done, try to share the link also to your friends so that they can also produce similar maps for their area of interest. And then I will see you in the next day of the map challenge. Thank you.